All right, so homework day 9, we're going to simplify other radical expressions other than just plain square roots. They might be cube roots, they might be fifth roots, they might be fourth roots. So the first one is a cubed root. So if I have my list of perfect cubes, 2 to the third power is 8, 3 to the third power is 27, 4 to the third power is 64, 5 to the third power is 125, and that's probably high enough. If you needed to keep going, you could. But if I'm simplifying the cubed root of 32, the principle is kind of the same as the one with the square roots. We want the biggest perfect cube that divides evenly into 32. In this case, obviously 125 and 64 are too big. 27 doesn't divide into 32, but 8 does. So we're going to factor this into the cubed root of 8 times the cubed root of 4, because 8 times 4 is 32. We're then going to go ahead and take the cubed root of 8. The cubed root of 8 is going to be 2, because 2 cubed is 8. So again, like the square roots, this should be a perfect cube. It's going to come out and it's going to be a nice whole number, a plain old 2 in this case. This is going to go behind it, the cubed root of 4. So we get 2 times the cubed root of 4 for our answer in simplified form. Now when you're doing the fifth power, if I do 2 to the fifth power, we know that one is 32. I don't even know what 3 to the fifth is in my head because I use it so little. What's 3 to the fifth power? You take your calculator and do 3 to the fifth power.
243.
243. See, they get big in a hurry, right? When you take it to the fifth power. So that's probably as long as I need my powers for fifths. So most of the time, if you're going to be able to simplify a fifth root, it's going to be because 32 divides into it, right? Because 32 is a perfect fifth power. So I'm going to say, okay, I've got the fifth root of 32 times the fifth root of 2, because 32 times 2 is 64. I'm then going to do my fifth root of 32, and my fifth root of 32 is 2. So there's going to be a plain old 2 in the front, that nice whole number 2, and then this is going to be go behind it, so fifth root of 2. So I get 2 times the fifth root of 2. Then the next one's doing the fourth powers. Fourth powers. 2 to the fourth power. 2 to the fourth power is 16, right? 3 to the fourth power. 3 to the fourth power is
81.
81. 4 to the fourth power.
256.
256. And again, we're getting kind of big, so that's probably long enough for that list. If you get bigger ones, you can always add to it. So when I'm looking at simplifying a perfect fourth power, is it divisible by any of these numbers? In this case, 48 is divisible by 16, right? So I'm going to say it's the fourth root of 16 times the fourth root of 3, because 16 times 3 is 48. And then I'm going to do the fourth root of 16. The fourth root of 16 is 2, again. So I'm going to have 2 times the fourth root of 3 for my answer. So most of the time when you're doing higher powers, because your numbers get big in such a hurry, 2s and 3s are about all you're ever going to be able to take out by the time you're done.